Oh wow, that's way back. Uh, I had a Commodore VIC-20 was my first computer. My parents bought it, and I was about 7 years old, I think, when I got it. And no one was really doing much with it in my family, but you know, we played a couple games and things like that. But a VIC-20 had 3.5K of memory. It was really constrained. There's not much you could do with it. But it did come with a programming manual. And had a basic interpreter in it. So I picked that up, and I don't know how I did it when I was 7, but apparently I did. I read through it and started typing stuff in, and promptly ran out of memory, even as a kid. But I was super fascinated by the whole thing, and really was excited about just working with computers, and really took to it. I was also lucky that I was homeschooled, and my parents were really cultivating anything that me and my brother were into, and that was just an area that and Legos, I think, were the two things that I was really into at the time. Later on, I got a Commodore 128, which was kind of the next model up from a Commodore 64, and had a luxurious amount of memory in it. I started playing a lot of Commodore 64 games, and that's where I started kind of getting a love for games, along with my real interest in programming and so forth.
Did you try to start making your own games pretty early on?
I did some level of success and some level of failure. I remember the first time I ever made a game, actually it wasn't programming. There was an old 8-bit game by Electronic Arts called Adventure Construction Set, and it allowed you to make some real primitive kind of adventure games, and that was a lot of fun. And so I made some sort of like Dungeons and Dragons sort of dungeon crawler games for my friends and things like that. So yeah. In the beginning, actually, I didn't really talk to or know many other people with computers, and so most of my connection was through magazines, actually, like Compute Magazine and Compute's Gazette and Byte and all of those. Those are fun because you type in the programs and things like that. So it's been really interesting to see kind of that connection. The other people with computers change from magazines all the way to the internet now and so forth. Yeah. Sometime in college, it occurred to me that this was what I was interested in and what I was taking classes in, and I should probably actually be serious about doing it professionally, because I don't seem to be good at much anything else. So.
Was like the game industry the first thing that came to mind, or was it just?
It was when I was in college. It was kind of the mid-90s, and that was the time that Doom had come out, and id Software was working on Quake, and I went to college in Dallas anyway, so there were a lot of people kind of really interested in kind of that era of game creation. That was when I think things shifted a little bit to where PC game development was a lot more accessible, and also that was the start of when you could start to really do 3D graphics, do really anything interesting in 3D graphics that didn't require a $10,000 workstation or something like that. So there was a lot of that was right before graphics accelerators even existed. So I remember everyone was writing their own software rasterizers and things like that. I've always been pretty interested in graphics, I think, probably because I kind of started in that era where graphics were kind of the newest kind of shiniest, flashiest thing, and that aspect of game creation where everyone was just shifting to 3D, and that was the kind of interesting part of it at the time. John Carmack would release a lot of information and talk a lot about what they were doing technically, and so that was really inspiring both to see how they put it together and also understand that that was also really a practical thing to do. I remember Michael Abrash also was kind of the same very kind of inspiring figure, and released a lot of information, and he released a couple of really great books, like the Zen of Code Optimization, and I think he also had the Zen of Graphics and so forth, that really kind of explained the nuts and bolts of how to do things.
what are the nuts and bolts of how to do things? Like,
Well, it's
It's
changed.
like-
I mean, it's changed dramatically over the years.
Yeah.
You know, when you're talking about a software rasterizer in the '90s, you're not talking about a graphics chip at all. I mean, what you're talking about graphics now is very different in terms of kind of the machines that you're working with and so forth. I mean, the nuts and bolts haven't changed that much in the sense that you're still dealing with triangles or polygons. You're still dealing with vertices that you have to transform. There's still texture maps, so there's a mapping between these 2D textures that you're working on into 3D space and so forth. So those sorts of nuts and bolts, a lot of the mathematics is the same. We're just doing it on a much larger scale. I think, unfortunately, a lot of console developers don't talk a lot about what they're doing with consoles outside of outside of the network for those consoles. That's because the information about those is pretty heavily guarded by NDA and so forth. So you can't just talk about, well, this is how we did such and such on the PS3's RSX, and this is what we did on the Xbox One's GPU and things like that. I wish that those were. I wish we could talk a lot more openly about that, because I think some of the really interesting development is inside those areas. Well, if you're a registered console developer, you usually, like, Microsoft has really great forums and Sony has really great forums where you can talk to other developers that are working on those platforms about platform-specific issues. So there is a lot of communication, and you can see how other people are doing things and so forth. You just can't publicly really discuss a lot of that. Yeah. That's why the PC space is interesting, I think, for indie developers also, because you're not hamstrung by these NDAs, and you can get a lot more information and share a lot more information about what you're doing. Yeah, it's an interesting part at Double Fine, because we don't concentrate on a single platform. We actually go pretty wide in our platforms, and that's a compromise and a trade-off. As a game developer and a programmer, I would love to just focus on one platform and get the most out of it and make the game really, really awesome on just one thing, whatever that is. But practically speaking, we have to stay in business, and so we do have to run on multiple platforms. And so there are a lot of interesting trade-offs there between what runs well on as many computers as possible versus actually spending time to develop software well for one particular platform, or you know, how much time do we want to spend on one versus the other. I think that's definitely true of the Xbox One and PS4 and high-end PC. All three of those platforms are actually very, very similar, really, at least from the point of view of what we're doing with them. I'm sure if you had a very giant budget and you were really, really targeting one particular machine for one particular game, you definitely find differences between them. But now, so much more than ever before, they're taking commodity parts and putting them into machines that are very, very similar, which is really good for Double Fine, because that means we can develop our tech and have it run well on multiple platforms.
Yeah, because I mean, there was definitely a time where, like, an Xbox game and a PS2 game they're not the same games. Not at
But the
all.
PS2 in particular, I spent a lot of time working on the PS2, and the PS2 in particular is probably the most interesting architecture I've ever worked with, meaning it is the most different from anything else, and it really resisted. It required that you write things very specifically for the PS2, and it was never going to be portable to anything else. So that's kind of the most extreme example that I've worked with, at least, of a machine that is unlike anything else. Yeah. Double Fine's Buddha engine is pretty well structured now to kind of compartmentalize different backends for different platforms and so forth. It didn't always used to be that way, but we've kind of worked on it over the years to make it a little bit easier to plug in different backends and so forth and upgrade things, which, as a programmer, I find really interesting and compelling to work with. So, yeah. When Massive Chalice started, actually, I was the only graphics programmer available at Double Fine, because Oliver was the other 3D programmer, but he was entirely working with Broken Age. So I was Massive Chalice needed some graphics work, so that was me. Early in pre-production, typically what happens is the art director or someone in that capacity will kind of define the look, and we'll do a little bit of look dev, and at that point we will take a look at the concept art and some of the examples and so forth, and kind of implement that in engine and make sure that it's reasonable and possible to do it all. And then once that's completed, we work on the tech a little bit more to actually prepare it for production. We went back and forth in the beginning a little bit to try to figure out the best ways to implement like the masked blending. In the case of Animal Crossing, we took a look at a lot of the screenshots and the videos and kind of scratched our head and like, well, how do you do this unless you are pre-baking these very large textures? How can we do this? And so I was thinking about that and trying to imagine some different ways of implementing that. I was ending up Googling a few different ideas and so forth about ways other games have handled blending layers of textures together. And that's when I found some of the stuff that Naughty Dog had done, and with texture blending, and it occurred to me we could do something pretty similar to do what Animal Crossing had done in terms of blending. But I think it did work out to produce something like pretty decent. Okay, so we were talking about the masked blend stuff. A good example is right here in the grass, or maybe right here where the grass and this other pattern meet up. But the artists have painted down vertex color, which you can see all RGBA here. But here we go one layer at a time, so that corresponds to the red layer and the vertex color, the green, the blue. Looks like they're just using the 3 layers there. And those correspond to different textures. So let's bring that up here. So here you can see different pattern textures that we use. So each of those different color channels will correspond to one of these textures. And then in addition to that, there's the alpha channel for the texture, which is what we're actually comparing with in the game in the layer blend here, to decide whether to use the upper blend, layer or the lower layer, and then we just keep stacking those up on top of each other to composite the final texture like this. Yeah, the idea is that the vertex color is slowly interpolated over a polygon, but that's compared against these hard gradients or hard values here in the alpha channel, and that has the effect of as the color slowly goes from black to white or from white to black, more and more of these patterns become invisible, and so you retain the original pieces of the pattern, but as it fades, pieces of that start to disappear until it eventually becomes 0 entirely. But that allows you to keep a lot more of the pattern inside that blend, rather than just doing a crossfade, which would just mush everything together. The CPU is actually just laying down a texture grid for the most part. The CPU just sees this flat mesh, and it just applies a single material in it and says, for that material, you're using these 4 textures. That's sent over to the GPU, who actually takes those 4 textures in the vertex color and composites them down to a single layer that it then shades and lights and outputs as the final color. I think it actually worked out pretty well because it was pretty cheap to implement on the GPU, and it was also, I think, pretty easy for the artists to set this up. You know, you have the different textures that you create, and all you have to do is paint down the vertex color in Maya, and it kind of blends together pretty well. So that's nice.
like in Rage when it introduced like mega textures.
Yeah.
And like, I mean, that sort of sounded like it was just like a gigantic drawing that was slapped down on the ground
Yeah.
instead of doing stuff like that. So it would just have like a huge memory footprint or something.
Well, megatexture was a really clever idea. It would also, and megatexture would be a great thing to implement in something like Massive Chalice. I guess another trade-off to make in there is time to implement, and the cost of in programmer time to actually implement something like that. So megatexture has the benefit that in the resident memory, like actually on the inside the computer, the memory footprint is pretty low, but it's constantly streaming back and forth from disk. But the time to implement all of that tech was more than what we really had in Massive Chalice's budget. Yeah. The code itself is not super complex at all. You can see it right here. This vertex blend is the vertex color, and then these layers right here have been fetched from a texture already. So that's the alpha values, and then essentially this is the line that does most of it. It just applies a smooth step between the layer alpha, and based on the vertex color right there. So that's the trick, and that will create a mask that then this actually does produce the color.
It seems like not a ton of code. I mean, is there more to it? Is this just like the top level?
No, this is most of it. The thing about shaders is you can't have a whole lot of code because you're running this for every single pixel on the screen. So you do need to be as quick and efficient as possible. So you do look for tricks to keep things kind of nice and concise. If this did become very, very complex and there was a lot of code here, then we would have to move back to a system where we were pre-baking things. But one of the nice things here is that it is pretty quick for the graphics chip to actually composite those layers together.
Is that like one of the biggest challenges, is to try to think of these procedures in the way that's like the most efficient, like the most streamlined as possible, so that you're not eating up a ton of resources?
When you're running in a pixel shader like this, when you're writing pixel shader, that is definitely a pretty big constraint. I mean, graphics chips are fast, but at the same time, people want to run at larger and larger resolutions, so they're definitely never fast enough. So that is kind of one of the big constraints, is to when you're writing a shader. I mean, creating an effect that needs to run in a pixel shader, write something that runs efficiently. Shaders are an energy field that surround us and penetrate us and bind us together.
It's like midi-chlorians.
Luminous pixels are we, not these crude voxels. The question is what are shaders? Shaders are just really small programs that run on a graphics chip, and they kind of have a loose definition. People toss around the word shaders to mean all kinds of different things. It generally means a fairly small snippet of code that does some kind of processing in the graphics pipeline. More precisely, when you're talking about a graphics chip, modern GPUs have a vertex shader. They have some other stuff now, but they mostly have a vertex shader and a pixel shader. So the vertex shader will actually take the triangles and plot them onto a 2D screen. They'll maybe animate them or do some skinning. Then the pixel shader will actually take the individual pixels that those triangles turn into and apply the texturing. So they'll take those 2D textures they create in Photoshop, apply them to the model, composite them together, and light and shade them, and maybe do some other effects like make them glow and things like that, and output those to the frame buffer, and then the frame buffer is what's actually displayed on the monitor. you actually get the the actual XY position in screen space of a pixel, but you can also pass other information from the vertex shader down to the pixel shader, so you can interpolate any kind of information you want across a polygon. So one thing that's pretty common is to get the world space position. So you have the position of the triangle in 3D, as well as the position in 2D of where it's been plotted to the screen, and you can do different things with that. So lighting, as an example, will probably be done in world space, because you have the kind of 3D object and you know where the light is, and you have to figure out how far away those are in 3D space. Other effects would be 2D, like if you wanted to do an image bloom to make the bright parts of the scene kind of glow out. Well, in that case, you are operating in 2D, and so you're actually kind of looking at the pixels to left and right and top and bottom and blurring them together to create the bloom. So in graphics, there are a number of different spaces that you have to transform between to do the work in. But it is pretty compartmentalized. There is kind of a pipeline of operations that you usually do. Go from model space to world space to view space to through the projection matrix to clip space, clip things, rasterize it, turn it into the pixel shader, and from there actually produce the final image.
Yeah, so what's helped you the most in your professional career? How is it sort of working? You've been in a few different studios, so just adapting to different cultures and things like that.
I think the important thing to remember is technology is always changing, and games are always changing. But especially the technology is always changing, and you either like that change and you embrace that, or you need to find something else to do, which is fine too. But I think kind of being passionate about new tech and understanding that it's always going to be changing is really important. Yeah. Yeah. Every studio I've worked at has had a slightly different engine and so forth, and always so keeping an open mind, obviously, about the best ways to do things, which may not be the way that they're doing them, and maybe it is, is important. When you change studios, also you can try to bring with you the best practices that you've learned from somewhere else, but there's also a limit to how much you can really reasonably change, because every studio does have a slightly different culture. Even the programmers and technology that they use is a little different. So it's been interesting to kind of work at a few different places and see how everyone does it. It's also been interesting in the Bay Area, because almost everyone that I've ever worked for or worked with is a LucasArts spin-off of some kind, and I think I'm starting to see little patterns of similarities between the way games are kind of written between studios. And that's kind of interesting. I say the passion that people have for games seems to be more at a smaller studio, and there's certainly a lot more. You have to wear many more hats, and you'll be a lot more hands-on with the entire game production cycle at a smaller studio as well. Larger studios are nice because you tend to be able to focus on one particular thing and do that really well. That's what they that's what they want, and that's why they have such large teams, so that people can specialize and so forth. So, but overall, I think that I get a lot of creative satisfaction from being involved in many different aspects of game production. Yeah, Double Fine is pretty. It's an interesting place because it's set up kind of from the start so that people. A lot of different people work well together, and so we don't have silos of different teams where people kind of are competitive. It's much more collaborative and so forth. And if Costume Quest needs some help, then maybe we'll borrow someone from Broken Age for a little while, or if Massive Chalice needs some help, maybe we can find someone who's not working on Costume Quest 2, or isn't quite necessary for Costume Quest 2, and people roll around and so forth. So that's been interesting to see and kind of adjust to that style of production.
I mean, since you're pretty focused on computer education from the very beginning, but like, What do you think were some of the like good choices that you made in order to find a career in this path?
Well, I think I did get a degree in computer science, and so I think pursuing an actual formal education in engineering is a useful is definitely useful. You'll in addition to that, I think for game programming, I think you'll find that a lot of people are pretty passionate about it as well. So some of the best hires that we made at Double Fine and around are people that had really good demos as well. So I think my advice for anyone interested in this style of work is to start making games and start making little demos of things, and whether they're you know a big game or a small little demo. It's I think it's best if you can demonstrate that you know how to kind of make something interesting and kind of take something and apply it to a computer and make the computer do something fun and neat and kind of eye-catching. Yeah. So there's a lot of there are a lot of great tools now. There's Shader Toy online, which is this website where you can just type in a shader live and see the result, and people have done some amazing things with that. Unity, obviously, there's it's really easy to dive in Unity and make all kinds of different things. Yeah.